Hola mates, this is Captain Jack. In the previous video, you must have seen that I didn't place a, a terminal for the 12 volt regulator. So before starting with the circuits, I will place a terminal for the 12 volt regulator. I will just name the wire as 12 volt 12 VCC plus 12 VCC. If we name two wires with the same label, it determines the software that these two wires are connected. Uh, we must remember that even the caps lock plays a vital role in naming the wires. So here we place the wire label for ground as well to show that this wire is connected to ground and the connection for the T block is done. So I will just start placing the components again. First we start with the board. We have selected the board edge. We can change the layer from over here also. So I'm making the regulator, the dual voltage regulator as well, in the 50 mm to 50 mm block. After we have made the board edge, we can start placing the components. First we start with the terminals. If there are any interference terminals like the T blocks or USB terminals, we start by placing them on the on the edge of the board. The board edge can be placed even after we place the components on the PCB design, but when there are some cases in which we want to keep the board size limited, as in this case the regulator size should be limited. That's why I had made the board first and then I'm starting to place the components. So I can change the names of the components to understand which T block is for what purpose each T block is serving. I can move the labels. So the TR1 and TR2 that we see in the component list are the transformers. They do not have a they itself. We'll refer the schematic again and again, as this is the first basic circuit that we are making. So after placing the input block, I'll start placing the bridge rectifiers. So each bridge rectifier has 4 diodes. So let's place the diodes. I'll keep the labels of the diodes inside the components so that I can get more space to place the components. Over here I'm keeping in mind that the green lines, the rat's nest lines, are as straight as possible and are not crossing each other. So here I have placed the rectifier bridge for the first circuit, that is the 12 volt and 5 volt circuit. Over here I place the second, I will start placing the second bridge. So now I have placed both the bridge rectifiers. Now the next part that comes in the circuit is the filter. the filter circuit, the filter capacitors, as well as the noise reduction capacitors. So uh, I better place the IC first, the regulator IC first. So over here I will try to keep the ICs together. First I'll place one IC, then I'll place the filter capacitor and the noise reduction capacitors. Let's see how much space one regulator takes. So over here the capacitor has much more straight lines, so we can place it over here, and the noise reduction capacitor along with it. Most of the time that is consumed when making a circuit uh, is while deciding how to place the components, because placing the components is very important when we're making a circuit. We are to follow the rules to reduce the space. So now we'll place the other noise capacitor, and another filter, the filter for 5-volt regulator. These noise reduction capacitors are better if placed close to the IC. I'm trying to make as less usage of space as possible. So let's play C5, the noise reduction capacitor for 7805. So first I will place the 7805 IC. It is coming well in the section of dual regulator supply. So I think I must replace some capacitors. Let's see. So I'm placing components over here according to my needs, according to the design that I have in mind. But every design, if we see the probability of making a same circuit by 100 users, if I give this circuit to 100 designers, 100 engineers to design a circuit for the schematic that I've made, every person will have a different circuit at hand. So it doesn't matter if you make a circuit similar to mine, but there are specific rules that we have discussed in the theory lectures that are needed to be followed when making a circuit. So now we take the filter capacitors for dual regulator supply. Okay, first we place the IC as we have done in the previous regulators. I'm making sure that I place the heat sinks away from the other components that can have effects of heat. Just a few more. Just this 6 capacitors remain. It looks like I can't place two electrolytic capacitors over here. It will be a bit overlapping components which we have to avoid. Let's see if we can avoid them. So the last capacitor. Let's see where we can find an efficient space to place this one. Okay, so I have placed all the components now. Now is the time where I can change the trace style over here, as you can see. So I will keep my default trace style as 40 thou, the width to be 40 thou, and I will start connecting the traces, the ratchets that are just straight lines that do not have any cross links anywhere. These power lines have to be of greater width. I will try to keep the traces as straight as possible. I will avoid the turns as much as I can. Life would have been much more easier if all the traces were so straight, but there will be a moment when we'll get stuck. I'm sure about that. So over here we can see how many cross connections there are in the circuit. I'll just first connect the straight one. Mm, I'm trying to even avoid the use of jumpers. Jumpers are jumpers are connections uh, like shorted wires that are used that are used when the circuit we cannot make a direct path in a circuit. So I'm trying to avoid the use of those jumpers. Uh, try to maintain the space between the pads of the components and the traces, as well as between two traces. Most of the time, as you must have observed, this is a small circuit, that's why the components were placed faster. But in the larger circuits, most of the time is consumed while placing the components on the board. And if you make a calculation about that, about the time consumed, so about 80 to 90% of the time is consumed while placing the components properly, and just the remaining 20% time is required for making the traces. This particular circuit is taking much more time because I'm making it on a single layer, but more the layers, more simple the circuit will be made. Talk about avoiding turns. I'm just taking so many turns over here. If the software is not working according to your wish, I would suggest one thing: don't get frustrated. Just stay calm and carry on. Hmm. So now, most of the connections we can see are cross connected. So I will try to make these connections as simpler as possible, avoid the turns. Y- One thing to be kept in mind, and I would like to repeat this again, I think I have said this earlier: every mind has a different design, has a different artist in them. So it's better uh, you don't try to make us connections like mine. You try to make your own connections. But this can act like a guide when you might feel stuck. So these connections are like crossing other traces. So I'll just try to make these connections much more simpler. I think this video is getting much longer than expected. So fellas, I would suggest you to stay tuned for my next video where we'll see some more features in PCB designing.